Alright, boys and girls, welcome to our last video lesson in Chapter 6, our lesson on kites and trapezoids. Alrighty, here we go. Alright, a kite is defined as a quadrilateral with two disjoint, love that word, disjoint pairs of consecutive sides. In other words, these two sides are congruent, and these two sides are congruent. In other words, the congruent sides are not opposite each other, they are adjacent to each other, they are consecutive. In a kite, there's a lot of properties which we call the half properties. Okay? First of all, the diagonals are perp. So these are perp, meaning we have a right angle. We have a right angle right here. Okay? One diagonal is the perpendicular bisector of the other. So in other words, we can see that DB will bisect AC. However, AC is not the perpendicular bisector of DB. One diagonal bisects a pair of opposite angles. And again, DB is a single bisector, is a single diagonal that bisects this angle. So this is congruent to that, and this is congruent to that, okay? And one diagonal bisects a pair of, I just wrote that, so that's 4. And now number 5, the pair of opposite angles not bisected are congruent. So in other words, this angle is congruent to this angle. And you can see now that the kite is kind of similar to a rhombus, but only it works, each of the properties of the rhombus works only half the properties for the kite. In other words, this is a half property, this is a half property, and this is a half property, while in a rhombus, they work for both of them, okay? An isosceles trapezoid, on the other hand, has a bunch of properties. We know that a regular trapezoid, the one pair of sides are parallel. In the opposite trapezoid, in the isosceles trapezoid now, the non-parallel sides are congruent. We call these legs. So these are called the legs right here. So these are the legs. Whoop. And this is a leg 2. And these are my bases, top base and bottom base, or vice versa, top base and bottom base. Okay, in an isosceles trapezoid, my legs are congruent. My lower base angles are congruent, so these are congruent. My bases are parallel. My upper base angles are congruent. I'll do that in red, so these are congruent. The diagonals are congruent, so BD is congruent to AC. And because we have parallel sides, a lower base angle, which is this one, and an upper base angle, those two things are going to be sup. Those two things are going to be sup. Okay? Okay, so let's review the properties of the kite. A kite, by definition, has two pairs of consecutive disjoint congruent sides, so those sides are congruent like that. The diagonals are perp, so that diagonal is perp to this diagonal, meaning that's a right angle. Now here come the half properties. One of the diagonals is the perpendicular bisector of the other, so AC bisects BD, but not vice versa. One of the diagonals bisects the angles. So in this case, this angle is congruent to this angle, and this angle is congruent to that angle. But however, these angles up here are not bisected. Okay, and the third half property is that the non-bisected angles, they are congruent to each other. In the isosceles trapezoid, by definition, a trapezoid has bases that are parallel. In the isosceles trapezoid, the legs are congruent. Also in an isosceles trapezoid now, the lower base angles, they are congruent to each other. The upper base angles are congruent to each other. consecutive or a lower base angle is supplementary to an upper base angle. And lastly, here we go, the diagonals are congruent in a trapezoid. Be careful here now, the diagonals of a trapezoid do not bisect each other, even though the diagonals of an isosceles trapezoid are congruent. Okay, one more definition we need to know, the definition of the mid-segment of a trapezoid. The mid-segment of a trapezoid is a line that is drawn from the midpoint of one of the legs to the midpoint of the other leg. And it's important to know now that the mid-segment will always be also parallel to the two bases, and the mid-segment is always the average of the bases. In other words, it is one half, the sum of the two bases is the length of the mid-segment. It's the average of the bases. All right, let's look at this problem. We have a speaker that's shaped like an isosceles trapezoid, which now means, as we know, that our legs are congruent, okay? We know that the bases are parallel. We know that our base angles are congruent, and we know that a base angle with the other base angle is sup, so like these two angles would be sup. Okay, it says that the measure of angle FGH is 85, so this angle right here, that's 85 degrees. And we know that FK is 8, there's K right here, so this piece right here is 8. Let me do that in red so we can see it. That piece right there is 8. And we know that GJ is a total of 19, which means now that this must be 8, and this is 11, and this is 11. Okay, so the measure of angle FGH is going to be supplementary to 85, so that's going to be 95, because angle J is sup to F, and angle F is congruent to G. So if this is 85, this is 95, and this is also now 95. And the length of KH, I'm looking for KH, oh, that's this piece right here. KH would be 11. I'm sorry, I was looking at the 19. All right, let's try a couple more. In the figure LH, LH is the mid-segment of trapezoid FJK. What's the value of X? Well, we know that the mid-segment is the average of the two bases. So base 1, 18.2, plus base 2, which is X, is equal to 15, and this is over 2. The average of the bases is equal to 15. I'm going to multiply both sides by 2, so I'm going to get 18.2 plus X is equal to 30. I'm going to subtract the 18.2 from both sides now. X is equal to 11.8. All right, so there's the upper base. If quadrilateral FGHJ is a kite, find the measure of GFJ. So again, what do we know about kites? We know that we have congruent sides. These two sides are congruent. We have congruent angles. These two angles will be congruent. And we have, if we drew them in there, the diagonals are perpendicular. But more importantly for this problem, we now know that this angle, F, is congruent to H, so let's call those X. So 2X plus 128 plus 72 is equal to 360, because the four angles of a quadrilateral add up to 360. It looks like 2X plus 128 plus 72 is 200, is equal to 360. 2X is equal to 160. X must be 80 degrees. In the second problem, WXYZ is a kite. Find ZY. Okay, we know that the diagonals are perp. So this side is perp to this side of my diagonal. Find the length of ZY. Well, we're going to have a right triangle, because that's a right angle. So now I know that 8 squared plus 24 squared is equal to x squared. I'll let you guys do the math yourselves. First three people to send me an email with that answer for x will get a bonus point on our next test or quiz. Okay, this last one right here, it's a proof. I'll help you out a little bit, but not too much because it's not that bad of a proof. We want to prove that the diagonals on an isosceles trapezoid are congruent. Notice we need to prove that AC is congruent to BD. But we can use our definition of an isosceles trapezoid and some of its properties to do this. I'll give you a couple of hints. I'm going to at some point prove that, I'll do this in red, that this triangle is congruent to this triangle in red. Okay, I can certainly use that CD is congruent to 8 to AB, and our reason for that is going to be def, or property of isosceles trapezoid, so def isos trap. Okay, I'm certainly going to have a reflexive step in here. And I'm going to have a property of isos trap, so isos traps have congruent base angles. I'm going to have an SAS and a CPC-TC. You guys fill in the steps. All right, we'll see you soon. Have a great day.